Okay, saya baru post the link for your attendance kat dalam chat room. So please click on the link yang berkenaan. Ikut your cohort.
Tak ada pun sir.
Sebab ni baru join kot. Kat sini ni kalau kita tengok kat screen, aku just copy. Okay, so it should be there. Okay, hari ni kita akan sambung our lesson. Kita masih lagi dalam chapter pertama. Hari ni kita go through introduction and I've asked you to watch the video tentang apa nama the plant tour of Maniaga. Okay, kita cerita last week about the flow, the process flow, macam mana ubat dibuat, okay, department apa yang terlibat, macam mana proses dibuat. Hari ni kita akan tengok QC. What is QC? Which is a component of the manufacturing process. Mana ubat itu dibuat. And also saya nak clarify, last week saya confused sikit about kelas hari Jumaat. So, bila saya tengok balik you guys punya master plan 35 and 36, hari Jumaat tu adalah kelas lab. Okay. So hari ini, hari Rabu ni adalah kelas lecture. So so kelas lab pun mulai minggu ini. So Jumaat ni akan mulalah. Okay, kita akan gabung juga 35 and 36. So sepatutnya kelas 36 mula minggu lepas, tapi saya hold off. So saya nak start together. So, maksudnya kita akan ada maybe kita buat satu kelas ganti lah untuk ganti kelas yang minggu lepas punya. Okay, maybe yang kelas sama dengan aku. Tengoklah macam mana nanti. Okay. So hari Rabu kelas lecture, hari Jumaat kelas praktikal. Okay, kita akan start, I'll explain macam mana kita nak buat virtual lab class lusa. Kamis Jumaat, yes lusa. 72, saya dapat notification yang kata heavy load. Ramai sangat orang. Jadi kena fikir other options. Alright. Okay, so kita mula dulu. Okay, so quality control. Macam saya cerita minggu lepas in our first class, quality control adalah satu is the part in the manufacturing process where the drugs, the products are being tested for quality and safety. Okay, dulu when I was working as a chemist, kerja saya adalah quality controller. I was a QC chemist. So what I did was, bila saya masuk kerja every day, I go into the lab. And I will be assigned for different lab, different drugs to be tested every day. So saya nak share kat sini one of the document. Mana ada PDF. So this is the document yang mana kami guna, QC chemist guna untuk rujuk sebelum kami buat sebarang test. So katakanlah this one day saya masuk dalam lab, what I need to do was saya perlu test ubat chlorpheniramine tablet. So it says here, Pharmaniaga chlorpheniramine tablet. This was an old obsolete document. So Pharmaniaga dah tak guna dah. I requested my kawan saya yang kerja lagi kat Pharmaniaga, dia minta ada tak yang dah obsolete tak guna dah, saya boleh guna untuk teaching. So this is it. So this document kita panggil the standard test procedure, okay, STP. So every time we go into the lab, kalau kita nak buat test, we will use this document STP untuk rujuk test apa nak dibuat, macam mana nak buat test tersebut. Macam mana nak tahu sesuatu produk tu pass ataupun fail sesuatu test. So for example here, ini adalah untuk chlorpheniramine tablet 4 mg. So dekat sini the first test yang perlu dibuat adalah appearance test. Kami perlu check rupa fizikal tablet tersebut. Okay, kat sini dia kata shelf and release limit. So release limit ni maksud dia dia punya standard lah. Kalau sesuatu ubat tu menepati release limit, pass the test, boleh dijual. So for example, dekat sini dia tulis the tablet should be yellow in color, the shape should be round, flat, bevel edge with a logo on one side and a score line on the other. So kalau kita check, usually kita akan ambil about 20 tablets. Okay, so 20 tablets will be taken randomly and kami akan check for the color, for the shape and for the logo on each side and a score line. So kalau for all these 20 tablets, ada ke semua ciri-ciri ni? Pass. Okay, so that's the simplest test, appearance test. The second test adalah identification. Okay, the QC chemists need to identify the API of certain drugs. Betul ke ini API untuk chlorpheniramine tablet ni chlorpheniramine malate? So kita perlu buat test untuk confirmkan. Sekejap, kawan kamu baru nak join. Okay, welcome Jocelyn. So identification test adalah test di mana kita buat untuk kita kenal pasti. We need to identify the API of the drug. So active ingredient, the API untuk chlorpheniramine adalah chlorpheniramine malate. Okay, the API untuk chlorpheniramine tablet adalah chlorpheniramine malate. So we need to identify betul tak betul dalam tablets ni ada chlorpheniramine malate. So this is how we are going to perform this. The method is TLC, which stands for thin layer chromatography, sejenis chromatography method. Ini cara-cara, these are all the technicals. Okay, dia punya chromatography conditioner, nak kena pakai apa, plate apa nak kena pakai, mobile phase apa. But the gist here is, saya nak kamu faham kat sini, kalau kita nak buat perform any test, especially any chemical test, yang bukan macam appearance tadi, usually we need to prepare two types of solutions. Okay, kamu perlu sediakan dua jenis larutan. Satunya adalah larutan sampel, your product, the drug, and satu lagi adalah larutan rujukan, larutan standard solution. So dalam case chlorpheniramine malate ni, the first solution ni, solution 1 ni adalah solution sampel lah, your tablets. Kamu kena ambil tablet chlorpheniramine malate tu, tumbuk dia, grind jadi powder, kemudian timbang 112.5 mg. Kemudian dissolve menggunakan chloroform. And then dilute, ambil 1 ml of that first solution tadi tu, and then dissolve dalam chloroform lagi. So this is the first solution. This is your sample solution, right? And then the second type of solution adalah your standard solution yang kita nak guna untuk compare with our sample solution. So this solution, macam mana nak prepare, timbang 50 mg of the reference standard. Chlorpheniramine malate ni adalah satu bahan yang mana dia hanya mengandungi chlorpheniramine malate sahaja. It's the same substance as the API. Kita nak kenal pasti API dalam chlorpheniramine tablet tu, ada API dia, iaitu chlorpheniramine malate. So kita nak kenal pasti, how do we know dalam tablet tu ada chlorpheniramine malate? So kita banding dia, kita prepare dua solution, satunya adalah solution tablet, satu lagi adalah solution standard yang mana dia hanya mengandungi chlorpheniramine malate sahaja. Okay, kita dissolve dia dengan chloroform, we get the two solutions. Kemudian kita run it on the TLC plate. So this is how a TLC plate works. Kita ambil a few drops of the two solutions, kita letak atas plate TLC ni, and in the end, at the end of the analysis, akan dapat two spots like this. So these two spots just basically means that dia membuktikan kehadiran API, membuktikan kehadiran chlorpheniramine malate. So kat sini dia label solution 1 and solution 2. So kalau kedua-duanya both the spots of both solutions are similar in terms of the distance. So macam contohnya solution number 1 ada 2 spots, solution number 2 ada 2 spots juga. So itu dah okey dah sama. Yang kedua, spots yang ke atas ni sama kedudukannya dengan solution 1 and solution 2. Spots kat bawah pun sama juga kedudukannya dengan solution 1 and solution 2. So that means kita boleh conclude dalam solution number 1, which is our sample solution, dia mengandungi satu compound yang sama ciri-cirinya. It has similar properties with chlorpheniramine malate. Okay, so therefore kita boleh conclude this substance here adalah the API. Kita dah kenal pasti the substance yang ada dalam chlorpheniramine tablet tu adalah chlorpheniramine malate. So the point why I'm showing you this SCP adalah untuk so that you get an idea, kamu boleh gambarkan macam mana sesuatu test dibuat di dalam mat-mat. Okay, so kat sini because later on kita akan discuss accuracy, precision. So for you to understand accuracy and precision, you need to at least have a basic understanding macam mana sesuatu test tu dibuat. Okay, so this is one example, identification test. Tujuan kita buat identification test adalah untuk kita kenal pasti sesuatu bahan. In this case, kita nak kenal pasti API. Betul tak betul chlorpheniramine malate. So ada banyak lagi test kat dalam ni untuk the number of tests vary depending on the product, tapi most of them lebih kurang samalah. Kita akan test dia punya appearance, kita test dia punya kita kena identify dia punya API. Kat sini kena check dia punya average weight per tablet, kekerasan pun kita test, variability kita akan go in detail dalam chapter 4. Uniformity of dose, kita nak tengok dalam 10 biji tablet tu dia punya dose sama ataupun tidak, sekata ataupun tidak. So this is test number 7, the solution. Kita nak tengok whether the API dissolve dengan elok ataupun tidak dalam sesuatu medium dalam badan kita. And lastly, related substance, kita nak tengok ada tak contaminants, ada tak bahan-bahan lain yang ada dalam kita punya tablet tu. And lastly is assay test, kita nak check itu kandungan of our tablet. Okay, so kat sini dia tulis shelf limit, release limit. Kalau produk tu baru siap, kita nak jual dia first time, kita tengok release limit. Okay, so for example untuk assay test, kita nak pastikan kandungan dalam sebiji 4 mg tablet tu, kandungan API jatuh antara 95 hingga 105%. Okay, the dose should fall within this range, antara 3.8 mg hingga 4.2 mg. So kalau kita test, we make 6 solutions and all of them should fall within this range. Okay, kita tak mau terlebih, takut jadi overdose bila patients makan. Tak mau kurang dari 3.8, takut tak berkesan. Bukan takut, memang tak akan berkesan because the dose is not enough. Okay, so that's why we need to make sure the least amount adalah 3.8 mg for chlorpheniramine tablet ni, the most adalah 4.2 mg. So kita kena test and kita tengoklah refer here the results. Kita dapat jatuh antara range ni ataupun tidak. So in this case, dia tulis kat sini method, kaedah apa kita guna, HPLC. Which is also a type of chromatography. And then these are all the technicals. Kalau kamu tengok kat sini, kita kena prepare two solutions juga. Pertamanya adalah your standard solution. Satu lagi adalah your assay solution, your tablets. So kat sini dia suruh ambil 20 biji tablet, grind, hancurkan jadi powder and then timbang 90 mg. Okay, and then masukkan dalam 25 ml volumetric flux and then dissolve. And that's your assay solution, the sample solution. The standard solution, kita prepare dengan chlorpheniramine malate juga. Kita check dia punya API, content of the API. So kita ambil chlorpheniramine malate working standard. So you have to understand chlorpheniramine malate ni dia boleh jadi a working standard, dia boleh jadi standard solution because we know the content, the purity. Kandungan dia mestilah tinggi dan juga stabil. Dia hanya mengandungi chlorpheniramine malate sahaja. That's how we know the purity is high. Kalau our tablets, the API tu dah bercampur dengan macam-macam bahan yang lain, other ingredients, other excipients like sugar, coating agent, bonding agent, all of these other ingredients yang need to be added to make up a tablet. So it is not pure. Okay, so kita kena bandingkan dia dengan sesuatu yang higher purity. So that's why we use a reference standard, a working standard. In this solution, it only contains chlorpheniramine malate, which is the same substance as the API of the tablet. So don't worry about the technical ni. Saya cuma nak kamu faham bila nak prepare, bila nak buat analysis. Usually we will make two types of solution, standard solution and your sample solution. So in the end, bila kita run this analysis dalam HPLC, kita akan dapat dua graph like this. So bila kita buat test menggunakan HPLC, it's an instrument, it is attached to a software in the computer. So all the work will be done by the software lah, by the computer. Kita boleh print out the graph and analyze the results. So in this case, dalam case chlorpheniramine tablet ni, dia akan print out, dia akan keluarkan two graphs like this, two with a peak. So ini adalah chromatogram. The graph for HPLC kita panggil dia sebagai chromatogram. So in this graph kita nampak satu peak tinggi dilabel sebagai chlorpheniramine malate. So this is the standard solution. Okay, so dalam standard solution punya chromatogram kita nampak satu peak and it is labeled as chlorpheniramine. So this is this machine HPLC ni detects chlorpheniramine malate dekat minit keberapa yang tertulis. Okay. So, graph ni is the x-axis of the graph adalah time. Berapa lama masa diambil for the instrument to detect this compound chlorpheniramine. So dekat minit ke-3, 3 point something minute, dia detect chlorpheniramine malate ada satu peak keluar. So this is chlorpheniramine malate. Kita tahu this is chlorpheniramine malate because dalam that standard solution, it only contains chlorpheniramine malate. Okay, and this peak, this smaller peak is not chlorpheniramine malate because it is a smaller peak. Size dia tak cukup. Ada grade peak, ada grade yang perlu dipatuhi for a peak to be recognized as a substance of the solution yang kita prepare. And this peak here is too small. Dia tak terlalu lebar, so it does not count as the peak yang kita prepare. So that's why this is the peak yang kita nak, chlorpheniramine. And then kita bandingkan, do not show this. Kita bandingkan dengan the peak, the chromatogram of our sample solution, kita punya tablet. So as you can see, similar. Okay, dia ada dua peak juga. The first one kecil, and then the second one yang besar kat sini. And then dia punya runtime, dia punya masa yang dia ambil for the instrument to detect this compound pun sama, 3 point something juga. Sama dengan the standard solution here, 3 point something juga. So bila kita bandingkan ni, dia punya masa yang dia ambil pun sama, size dia pun lebih kurang sama. And then kita boleh conclude that, kita boleh conclude that this peak here is also chlorpheniramine. So this is the API of the tablet. Kita dah detect that. Kemudian kita boleh gunakan this formula untuk calculate the amount. Berapa banyak, berapa miligram yang kita detect. So if you follow this formula here, isi, kita ambil the area di bawah graph. The software will do the calculation. Okay, kalau tak ada software, orang dulu before there is a software, dia akan print out graph on a piece of paper, dia akan buat integration. If you still remember calculus, dia akan kira the area under the graph. Dia perlu buat kamera. That's the Malay word, if I'm not mistaken. Okay, integration untuk cari the area under the ground, sample area, standard area, and then do the same lah. Darab dengan the amount of standard, banyak ketimbang tadi, and then darab ni, and then kita akan dapat. So the value here should fall within the range yang kita tengok dekat atas tadi, iaitu 3.8 hingga 4.2. So kalau dapat within this range, pass lah. Kalau fundamental tu pass, boleh jual. Pass essay test. Kandungan dia menepati standard. Okay, so that's basically how we perform. Macam mana QC perform analysis dalam makmal. Okay, don't worry about all the details. Saya cuma nak kamu faham, ada banyak test, ada pelbagai kaedah. Dalam case chlorpheniramine tablet tadi tu, saya tunjuk macam the first one adalah appearance. That is also an analysis. Kita just assess secara physical. Ambil sebiji tablet, tengok color, tengok dia punya shape, tengok logo apa ada on one side, ada apa on the other. That is a type of analysis. Okay, qualitative analysis. The second contoh yang saya tunjuk adalah identification. Okay, identification tadi kita buat pakai kita tengok spots tadi tu. Also a qualitative analysis. Okay, kita guna TLC, thin layer chromatography. And kita kena prepare two solutions, standard and sample. And then the third analysis yang saya tunjuk tadi adalah assay test. Kita prepare two solutions juga, standard solution and your sample solution. It's okay Aizat, tak apa. Okay. So apa yang saya nak kamu dapat from the benda yang saya tunjuk itu adalah understand there are many tests many tests to be done on one tablet. And macam mana kita nak perform test tu, ada pelbagai, and then one of them adalah yang saya tunjuk tadi adalah TLC, HPLC, ataupun kita assess dengan mata kasar saja. Okay. So test ni juga ada pelbagai sebab kita nak test different aspects of the drug. Kita nak pastikan ubat itu berkesan. So kita mesti check dia punya dose mencukupi. Kita nak memastikan ubat itu selamat dimakan. So kita kena identify API dia betul ke tak betul. Okay, maybe production ataupun warehouse buat silap label the API, sepatutnya nak buat chlorpheniramine, dia timbang PCM punya API, dia label chlorpheniramine. So bila buat tablet chlorpheniramine, termix dengan API PCM. So bila patients makan, dia ingat makan chlorpheniramine, but actually ada API PCM. So it won't work. So we have to do identification test to confirm betul-betul that is the drug that we claim to be. Okay, so that is basically my introduction to QC. What a QC department do. Dia akan perform variety of tests so that the drugs are safe and efficient bila dimakan. Okay, that brings me to the lecture note. Okay, kamu boleh refer, kamu boleh download lecture note ni dalam Google Classroom, already available. Okay, so quality control, what is it exactly? Apart from all the analysis yang saya dah cerita last week and today, basically secara kasarnya QC ni is dia buat kerja, and kerja dia tujuannya adalah untuk control error in analysis. Okay, because bila kita buat sesuatu analysis, ada pelbagai cara untuk buat analysis, and ada pelbagai kaedah. Okay, bukan HPLC saja boleh guna, TLC boleh guna, boleh buat titration macam-macam. So kita mesti follow a certain set of guidelines, certain set of rules untuk pastikan kesalahan ralat yang mungkin dibuat itu kurang. Kita nak kurangkan risiko untuk buat salah. Okay. So this is one example, one analysis for QC analyst yang perlu buat. So consider kat sini saya tanya, consider an analyst is given 100 PCM tablets and they claim the average of 10 tablets is 3 grams with plus minus 10% deviation. So macam mana kita nak test this claim? We could do this. This is how we do it. Okay, before saya go through that, let me clarify lagi sekali. Okay, this is one of the tests. Kat sini dia kata kalau saya masuk lab one day and saya diberikan 100 biji tablet, and then production personnel yang bagi saya this 100 tablet ni kata the average of 10 tablets adalah 3 gram with plus minus 10% deviation. So this is the requirement lah, okay, mesti plus minus 10% deviation. So my question is, what is this test and how do we perform this test? So macam mana kita nak test betul tak betul apa yang dia kata tu. So basically apa yang dia kata plus minus 10% deviation tu kita panggil dia sebagai tolerance, because kita tak tahu timbangan kita tu tepat ataupun tidak, okay, precise ataupun tidak. So there is a room for uncertainty, ketidakpastian. So this is allowed, this uncertainty is allowed by a certain amount. In Malaysia, orang yang tetapkan this uncertainty ni adalah NPRA, okay, the organization that gives out license to operate. Okay, kilang-kilang semua yang operate di Malaysia ni dapat license daripada NPRA, National Pharmaceutical Regulatory Affairs, NPRA. So kalau kita nak follow buat any test, all of them must be approved by NPRA. Okay, so this amount plus minus 10% ni is approved by NPRA lah. And kita kena test whether this ubat yang kita baru terima ni betul atau tak betul within 10% deviation. So in this case dia kata kalau plus minus 10% deviation, that means the minimum weight adalah 2.7. How do I know it's 2.7? Tunggu dah keluar. So kat sini where's the cursor? Okay, so dia kata kat sini plus minus 10%. Okay, this is kita panggil sebagai tolerance. Tolerance. Okay, so this plus minus 10% tolerance ni basically dia kata dia bermaksud the minimum and the maximum weight accepted. Okay, so in this case saya dah tulis kat sini the minimum weight adalah 2.7 gram, the maximum is 3.3 gram. Tapi the weight of the tablet dalam formulation kata sepatutnya 3 gram. 3 gram is listed here, saya dah tulis kat sini. Sepatutnya 3 gram. Tapi kita ada plus minus 10% deviation. Okay, maksudnya boleh lebih 10%, boleh kurang 10%. So kurang 10% daripada 3 gram adalah 2.7. So in this case lah, kat sini this is minus 10%. Kat sini 3.3 ni kita plus. Sorry. Kita plus 10%. So kalau 10% daripada 3 gram dapatlah 0.3 gram. 0.3 gram. So bila ditambahkan dengan 3.0, that's how I get 3.3. The same go for minus 10 ni. Sorry. 2% darab 3 gram dapatlah 0.3. So kalau 3 gram tolak 0.3 dapatlah 2.7. So that's how I got this value, 2.7 and 3.3. So this is the minimum amount of the tablet yang diterima. This is the maximum amount. So kalau saya nak test this claim, apa yang saya boleh buat adalah saya akan ambil 10 biji tablet, as I say here. Okay, ambil 10 biji tablet, timbang satu-satu. Timbang satu-satu dan cari average. Oops, sorry. So katakanlah saya ambil the first tablet and saya dapati berat dia adalah 3.2. Ambil the second tablet 3.0. Ambil the third tablet 2.9 gram semuanya, timbang berat. And the third one, the fourth one 2.5. Buatlah sampai 10 biji tablet. Okay. Buatlah sampai 10, 3.0 gram. and then find the average. So if the average is within 2.7 hingga 3.3, so maksudnya the claim is correct. Betul lah apa yang orang tu kata. The production personnel yang bagi kat saya tu, dia kata the each tablet average adalah 3 grams with plus minus 10% deviation. Ini kita panggil sebagai average tablet weight test. Okay, because kalau kita tahu dia punya average tablet weight adalah within this range, maksudnya the dose of the drug is okay, pass. Okay, it is according to standard average tablet weight test. So that is one example how we perform another test, iaitu average tablet weight. Okay, so kalau kamu perasan kat sini ada banyak dia punya inilah, it's very technical. So why is it very technical? Because kita nak limit error. So this is what analysis is about. Because ada pelbagai cara untuk buat test, different people will perform the test, bukan orang yang sama. Okay, different people will perform the same kind of test. So ada banyak kebarangkalian for errors to happen. So kita mesti control. We have kita mesti ada satu cara, satu kaedah yang kita boleh control error. So bila semua orang buat kaedah yang bila semua orang buat the same test, tapi kaedah yang digunakan mestilah sama. Okay, macam going back, maybe kamu tak faham tu. Contohnya macam nak menimbang. Okay, kamu boleh ada dua cara untuk menimbang. Kamu boleh guna a digital scale ataupun you can use a weighing scale. Both will give you a reading on a weight of something. Tapi one of them is more accurate, one of them is more efficient. So kalau kalau kita nak test sesuatu benda, kita nak bacaan tu sekata, uniform all the time. Kalau kamu nak buat kek, takkanlah hari ni kamu nak guna digital scale, esok kamu nak guna a weighing scale, and then lusa kamu tukar balik digital scale, and then ulang-alik. So your readings will be different, and then your result kek yang kamu buat tu maybe tak sama. Maybe one time guna digital scale you get a good cake. Tapi kamu the next day digital scale kamu rosak, you use a weighing scale yang macam neraca tu, you need to weigh kena timbang your ingredients and another weighing stone on the other side, maybe not as accurate as the digital scale. So your cake will not be the same as yesterday. So kita tak mahu this error. This is what I mean by error. When we change methods, when we change instruments, kita give room for error. So QC is all about limiting room for errors. So everybody buat benda yang sama, the same time, the same way, with the same instrument. That way kita boleh limit error, kurangkan kesalahan. Alright, so I hope I get that across. Okay, cakap pun tabak. Okay, so this is why errors are very important in analysis. Okay, because from the types of errors that we do, kita boleh kenal pasti sama ada kita ni tak accurate ke, sama ada kita ni tak accurate ataupun kita tak precise ataupun kita kedua-duanya. Okay, so basically there are three types of error. After kita habis this error, kita take 5 saat. So basically we have three types of errors: gross error, systematic error, dan juga random error. So the first error ni is all over the place. Major breakdown in the analytical process. Okay, contohnya kat sini saya bagi samples tu tertumpah tapi kita tak prepare baru. Kita just use whatever is left in the flask. Okay, katakanlah sepatutnya kita prepare 100 ml solution and then somehow accidents happen and then most of the solution spilled, tertumpah. So tinggal like 20 ml saja. So katakanlah kamu malas, you just use the 20 ml and then kamu dapat result. So the result will not be consistent as the standard lah because tertumpah, concentration tak sama. So number 2 adalah wrong dilutions being prepared. Sepatutnya kamu dilute sampai katakanlah bila dah tumpah tadi tu, kamu top up balik. So the concentration will be reduced because kamu dah cairkan dia lagi. So wrong dilutions are prepared. And another example saya bagi adalah instruments rosak. So kalau all of this all happened, this is what we call as gross error. Everything from the beginning, from from the analyst, orang yang buat kerja tu salah, kaedah yang digunakan pun salah, instrumen yang digunakan pun problem. So this is what we call gross error, major breakdown in the analytical process. Okay, so dalam sebarang analytical process, basically kita ada 3 komponen lah. Ada kaedah apa kita nak guna, orang, the analyst, the person that is performing the analysis, and the instrument that is being used. So if all 3 of them are went wrong somewhere, that is the gross, that is known as gross error, a major breakdown in the process. The second one is systematic error. So this is an error in, kalau contoh adalah in making measurements, kita buat kesalahan tu berulang kali, repeated inaccuracy in making volume measurement. So kat sini, this is why I show, saya share this STP tadi. Okay, so dalam this, saya ambil contoh assay test ni. So bila kita nak perform assay test ni, selalunya kita akan prepare these solutions in duplicate. So kita akan buat more than one. So the requirement for assay test ni, kita perlu prepare this assay solution ni sebanyak 6 kali. So we need to prepare 6 solutions. Alright, so kat sini dia suruh grind the tablets, okay, finely powder 20 tablets, and then weigh accurately 90 milligram of the tablets, and then dissolve dalam 25 milliliter volumetric flask. So what it means here, dia suruh, saya nak explain systematic error tadi lah. So saya ambil contoh this assay test ni. So dia suruh kita prepare this assay test. Nak prepare solution, kita kena prepare duplicates. Okay, so kita kena menggunakan volumetric flask. This is the first one. This is the second one. This is the third one. This is the fourth one. Okay, due to the size, saya buat 4 saja. Okay, so each of them kita perlu dimasukkan 90 mg, 90 mg of the chlorpheniramine powder tadi. Sini pun masuk 90 mg. Ini pun masuk 90 mg. Ini pun masuk 90 mg. Benda yang sama, tapi kita prepare multiple duplicates. Tujuannya adalah untuk make sure kita punya timbangan tu uniform. Sekata every time sepatutnya 90, so it should be 90. So for example, katakanlah saya buat test ni, saya tersilap baca. So I read the STP sepatutnya 90, tapi saya terbaca silap 70. So instead of 90, saya timbang bahasa cursor, saya masukkan 70 saja. 70. My bad, sorry. Saya nak tarik this. Okay. So saya masukkan 70 mg. So bukan, the second one pun saya silap, saya masukkan 70 mg. Ini pun saya silap, 70 mg. The last one also 70. So bila saya buat this analysis, saya masukkan dalam HPLC instrument, the reading won't be up to standard lah, because sepatutnya saya prepare a concentration of 90 mg dalam 25 ml. Tapi saya prepare 70 mg. And I repeat this mistake in all the duplicates. So from here, saya boleh tahu, because from the result yang saya dapat, semuanya salah, tapi semuanya sama. Bacaan dia sama. How do I know sama? Maybe sepatutnya dapat, where's the cursor? Where's the cursor? Give me a minute. Okay, sepatutnya assay test dapat 3.8 hingga 4.2 mg. Katakanlah for this 4 test yang saya prepare ni, this one dapat 3 mg, the dose, the content, ini pun 3 mg, ini pun 3 mg, ini pun 3 mg. So maybe kat sini from the result ni, of the 4 sample solution ni, semuanya tak menepati standard. Sepatutnya dapat within 3, paling rendah 3.8, paling tinggi 4.2. Sepatutnya dapat within this two range lah. Okay, 3.9 ke 4 ke 4.1 should be fine. Tapi saya dapat 3 for all of these solutions. So that means I made the same mistakes again and again. So I can go back, saya tengok balik all the logbooks. Okay, saya check balik STP. Okay, this is where I did wrong. Instead of weighing 90 milligrams of powder, I weighed 70 milligrams in all of the duplicates. So this is known as systematic error. Mana mouse? This is known as systematic error. Where's the slide? Okay, so systematic error is repeated error in making measurements, ataupun repeated error in making dilution. So whatever it is, whatever you do, if you did the error repeatedly, that is known as systematic error. Okay. Next adalah random error. So this is kalau contohnya dalam making measurements, timbangan ke mengukur ke, I did the error randomly. Okay, so going back to the same thing here. Okay, katalah saya prepare duplicates untuk chlorpheniramine. Okay, I need to prepare duplicates. This is the first one, the second flask, the third flask, and the fourth flask. Okay, sepatutnya kena timbang 90 mg. So katakanlah masa the first timbangan I weigh correctly 90 mg masuk dalam ni. Okay, and then the second one, maybe tangan saya bergegar ke, okay, some of the powder bila saya nak dah timbang, saya nak masukkan dalam ni, tertumpah jatuh kat sini and saya tak perasan. So instead of 90, maybe 80 milligrams only go in. And then the third one, maybe tengah melawat dengan kawan kan, masa tengah buat timbangan dan nak masukkan dalam ni, so tertumpah lagi, 60 milligrams saja. And then the fourth one, okay, kawan dah pula buat kerja dengan betul-betul. So 90 milligrams balik. So this is random error because the measurements are all over the place. Ada the first one correct, betul, second one salah, the third one salah, and then the fourth one betul balik. So kalau saya buat, I run this solution in the HPLC as intended, saya dapati the range here is, okay, sini betul 3.9, ini dah tak betul 3.0, ini lagi dah rendah 2.7, ini 4.0. So these two are within the standard, pass. Tapi ini salah. So kat mana salah, I can go back, check balik timbangan betul ataupun tidak, because when we perform timbangan, bila kita buat timbangan, kita kena record all the weighing, all the values. Okay, sepatutnya 90 mg, maybe kat sini buat salah. Kita ingat balik, oh, okay, tadi duduk melawat dengan member masa duduk buat timbang, duduk tepuk-tepuk belakang, tepuk-tepuk tangan, maybe tertumpah sikit. Maybe somebody open the door masa tengah buat timbangan, ataupun aircon suddenly, kipas aircon terkuat, so some of the powder ditiup jatuh, dia tak go into the flask. So that could affect your measurement. Okay, so this is known as random error. Dia punya kesalahan tu, error tu is at random. Dia tidak systematic. Dia punya, kita boleh detect by tengok at the results lah. Random ke systematic. Ada somebody ask a question? Ada pun, tapi dengar macam bunyi notification. Okay, so that is random error. So that is the 3 types of errors yang kita guna untuk detect whether we are accurate ataupun we are not. Kita ni precise ataupun we are not. Right? So why do we do that? Okay, macam saya cakap tadi, if we understood the errors, we can assess whether we are accurate or not. We can assess whether we are precise or not. So this is why we need to know what exactly is accuracy and what is precision. Okay, so kita take 5. Later when we come back, saya nak buat satu quizzes lesson. Okay, so kita akan guna quizzes lesson untuk go through this accuracy and precision punya topic. Yeah, take 5 side. Okay, I'm back. Okay, so let me share. Okay, hopefully semua masih bertahan. Saya dah check dengan quizzes tadi, tapi saya rasa kamu semua ni ramai sangat kot. Ada 70 berapa ni? 81, 80 excluding me. So kita tak akan buat the exercise. Saya bukan nak buat quiz because ada orang WhatsApp saya tadi. Whether we are going to have a quiz after the break tadi. So kita tak akan buat quiz, cuma saya nak buat like an exercise lah together. Saya nak participation from students also to check whether you understand or not. Saya tu sembang sama-sama. Tetapi considering the internet connection, the bandwidth, ramai sangat orang, so saya rasa quizzes akan like membebankan lagi my connection, especially because last week pun ada problem kan, so dengan Google Meet saja ni nak tambah lagi quizzes, so saya akan buat saya akan continue the lesson without the ni lah quizzes ni. So this is what we're supposed to do, but saya akan bagi like homework quizzes. Okay, so homework quizzes ni dia bukan like a grade, takkan dikira sebagai grade, saya just nak tahu your comprehension, saya nak assess whether you understand or not this topic, accuracy and precision. Okay, kita nak sambung balik accuracy and precision, where's the lecture? Okay, and by the way, saya tak explain hari tu last week dalam first class, the syllabus of instrumentation analysis ni, the things that we are learning, the content of this module is basically all the things that I did when I was a chemist dulu. So these are all the skills, in theory, the skills that you would need to have if you are going to be an analyst, a chemist. So, for example, if you the reason why I'm telling you this adalah, for example, if you want to venture out of the into a different path, kamu tak nak masuk bahagian pharmacy, kamu nak sambung degree, tapi kamu tak nak buat pharmacy. Kamu nak kerja, tapi kamu tak nak kerja as a pharmacist. You could venture out into kerja ni lah, analysis. Okay, kalau kerja, kamu boleh apply working as an assistant chemist, the title for diploma holder lah. Okay, assistant chemist ataupun QC technician. Kalau kamu nak sambung degree, you can masuk pharmaceutical chemistry. Dekat dalam degree PGWC pun boleh apply for DPS, pharmaceutical science. Okay, so you could venture out from pharmacy. Okay, kalau kamu tak nak kerja dalam bidang pharmacy, kamu boleh masuk dalam bahagian analisis. Okay, because the things that we are learning in this adalah all the skills in theory for you to be a chemist, to be an analyst. Okay, daripada A to Z semua dalam ni ada benda yang saya buat dulu. Okay, so this is an option for you kalau if you are considering a different path than pharmacy. Okay, sambung balik. Saya dah share screen belum? Still recording. Okay. Okay, so accuracy and precision. So I was telling you a story about errors just now. How is it important? QC is all about controlling error. So why we are all about controlling error adalah because kita nak jaga kita punya accuracy and kita punya precision. So what exactly is accuracy and precision ni? So the first thing yang kita nak go into adalah accuracy, ketepatan. If you remember dalam SPM, if you take physics ke? Chemistry, I don't remember. So that's the first where I've learned, I myself learned about this, accuracy and precision. Okay, so what is accuracy? Dia adalah kebolehan, the ability to measure or calculate a value closest to the standard value. Kebolehan sesuatu benda ataupun kebolehan seseorang untuk mengira sesuatu bahan close, paling dekat dengan nilai dia, nilai sebenar dia. Okay, so for me, one way for me to explain adalah kalau macam saya nak timbang berat badan saya selalu guna example ni. Let me go to the whiteboard. What's the whiteboard? Let me enlarge this. Katakanlah saya nak timbang berat badan saya. Okay, so kalau saya nak, I'm on a journey of losing weight. Okay, so kalau saya nak lose weight, I need, on the first day saya perlu tahulah berat badan saya berapa in order for me to tengok ada progress ke tidak. Katakanlah after dah a month, berapa kilo dah turun. So I need to know the initial weight. So berat badan pertama saya tu saya kena timbang dulu. So in order for me to make sure saya punya berat tu accurate, saya kena timbang dengan alat yang accurate, alat yang tepat. So saya beli penimbang yang baru, I buy this weighing scale online. Press the cursor. Okay, I buy this weighing scale. So this weighing scale I got online. And then bila dia sampai pada saya, dan saya timbang, I get on it, katakanlah bacaan berat badan saya adalah 80 kg. So I take this reading at 9 AM. Okay, so in order for me to know this is accurate or not, I need to take multiple readings lah. Okay, ambil bacaan banyak kali. So katakanlah at 12 noon, 12 PM, saya timbang berat badan saya, dia kata berat badan saya dah 90 kg. So that doesn't make sense. Okay, there's no way I could gain 10 kg in the span of 3 hours. So I suspect this weighing scale is macam pening zat. Okay, something is wrong. So I waited, katakanlah saya tunggu pukul 9 malam lah, after 12 hours. So kat sini, apa nama, bacaan yang dia bagi adalah 75 kilo lah. It goes back down. So bacaan tak sama, the 3 times that I used to measure myself. So something is wrong with this weighing scale. So how do I know which one is my actual body weight, 80 ke, 90 ke, 75? So I need to compare this weighing scale to a weighing scale that is already good, already certified, approved. This is the most accurate weighing scale. So for me to do that, for example, I could go to any hospital. Katakanlah saya go to a KPJ hospital, saya nak ambil berat badan saya. So I go to a KPJ hospital untuk timbang berat badan because we have accepted that the weighing scale at these hospitals, at any clinic, pharmacy, they are all good lah, up to standard, because they use those scales untuk dispense ubat. Okay, untuk buat all dia punya kerja-kerja kat hospital, klinik, pharmacy, semua use that weighing scale. So kita anggap all the weighing scales at these places are good, up to standard. So all the readings with using the weighing scale at the hospital, kita ambil kira sebagai tepat. So katakanlah saya go to KPJ hospital, mana dia? KPJ, and then saya step on the scale. Berat badan saya yang saya dapat adalah 80 kg. So katakanlah saya nak make sure saya timbang lagi sekali, the second time masih lagi 80 kg. And then the third time saya test lagi pun masih lagi 80 kg. So that means using this weighing scale yang dah di-approve dia punya quality, so saya dapati berat badan saya adalah 80 kg. So this is the real value. This is the standard value. Standard value. Okay. Oops. Standard value. Inilah berat badan sebenar saya. So that means this is the, where is it? This is the berat badan sebenar saya. Tapi the problem with this scale adalah dia set naik 90. Set turun 75. So this here, dia tak boleh bagi bacaan yang accurate because the closest as the actual value adalah 80. Tapi dia tak boleh bagi bacaan 80 kg all the time. So this scale yang saya beli online ni tidak accurate. So I need to get a new one. Maybe I need to complain, get a warranty, ataupun get a new weighing scale from the supplier. Okay, so that is basically what accuracy means. Kita tahu the real value, the standard value, and then kita compare our measurements with the standard value. So if it's close to the standard value, that means we are accurate. The person who are performing the analysis is accurate. The instrument that is used in the analysis is accurate. Okay, in this case, the analysis is menimbang, kamu timbang berat badan. Okay, that is accuracy. Precision pula, okay, in this lecture note of mine, saya kata precision is the ability of a person ataupun or an instrument to produce the same reading again and again. The ability to reproduce the same result again and again. So for example, kalau kita tengok balik this weighing scale yang saya beli tadi ni, the same result yang kita nak reproduce tu adalah the closest value. Okay. So the closest value adalah 80. So kita nak dia weighing scale ni boleh reproduce the closest value ni multiple times. So in this case, the first reading dapat 80, which is good. Okay, this is the real value. Tapi the second time tak dapat 80, dapat 90. The third time dapat 75. So dia tidak precise. This weighing scale tidak precise because I could not be the problem. There's no way I could gain 10 kg dalam masa 3 jam. Okay, antara 9 pagi hingga 12 petang takkanlah saya boleh naik berat 10 kg. Daripada 12 tengah hari sampai 9 malam takkanlah saya boleh turun 15 kg. That doesn't make sense. So that means the problem comes from the weighing scale. So this weighing scale is not precise. Okay, because precision means saya boleh reproduce the same results again and again. So kalau kita tengok dekat this KPJ weighing scale yang saya pergi dekat KPJ hospital ni, all 3 times dapat real value 80, the first time dapat 80, the second time dapat 80, the third time dapat 80. That means this weighing scale is not only accurate but it is also precise. Ini ciri-ciri yang ideal lah on a person, an analyst ataupun on an instrument. Yeah, dia mestilah accurate dan juga precise at the same time. So kalaulah sesuatu measurement tu, sesuatu reading tu tak precise macam ni. Okay, kalau kita nak analyze this weighing scale, kat mana salahnya? What is the error here? Start 80, start 90, start 75. Where is the mistake? So it could not be from the person because there's no way I could gain and lose weight that fast within that amount of period of time. So that must be something in the weighing scale. Maybe the spring tak betul, it could affect the reading. So if we change the spring, could that fix this problem? So we could see here, this error here, kamu nak kata systematic ke random? The first one 80, the second 90, the third is 75. So this is not a systematic error because kesalahan dia bukanlah repeated. Kesalahan dia secara rawak, random. Start 80, start 90, start 75. Okay, kalau systematic error, this weighing scale should give out reading 80, sorry, let me rewind that. The first one dia bagi 75, sedangkan berat badan saya 80. The second reading saya timbang saya 75 juga. The third one 75 juga. Okay, so bacaan dia sekata, okay, dia tidak accurate because berat badan sebenar saya adalah 80. Tapi dia precise. Dia boleh give out the same reading again and again. That could be the case also. Okay, dia precise, machine tu precise tapi dia, machine tu accurate tapi tak precise. Machine tu precise tapi tak accurate. So from here we can analyze. Kalau bacaan dia tidak accurate tapi precise, where is the mistake? Error dia rosak kat mana? Kita boleh investigate. So kalau kita tahu dia punya type of error, kita boleh we know where to look. Okay, which part of the component of the scale that could cause this. Okay, this is why we need to understand accuracy and precision. So kalau kita buat analysis, kita prepare multiple duplicates of solution, dia buat and the final result of the solution, kita tengok okay, mistake dia random. So what could cause it? Kat mana? Bila kita buat timbangan ke, bila kita buat dilution ke, we could investigate. Okay, we could determine the cause of error faster, more efficient. Alright. So to go deeper into this, so let's take a look at this slide. Dia tunjuk perbezaan antara 4 students. Okay, so there are 4 students and all of them are tasked to prepare and to perform an essay test on PCM tablet. Okay, and semua keempat-empat mereka perlu prepare 6 duplicates of solutions. So this is the results of the essay test lah. So student number 1 ke atas sekali, student number 2, number 3 and number 4. So this graph here, it shows the percentage of the essay test. So essay test is the test that we do to determine the content, the dose of a tablet. So kat sini dia perform this test untuk determine the content of this PCM tablet lah. So the goal is, the standard, the real value is 100%. We want the dose to be within 100%, close to 100%. Okay, so kalau kita nak assess the accuracy and the precision of the analysis, kita tengok pada dia punya reading. So the first student here, dia kata first student here ni adalah precise. This student is precise and accurate. So why is this student precise? Because all of the readings are close to each other. So that means dia boleh duplicate, dia boleh reproduce the same results again and again. Kenapa dia accurate? Because all of the duplicate solutions give out percentage close to close to 100%. So by definition, accuracy is being able to give reading close to the real value, which is 100 in this case. So this person is accurate. This person is also precise because they will repeat the reading 5 times. Sorry. So again and again. So that's why they're precise. So let's take a look at student number 2. Dia kata kat sini, this student is precise and inaccurate. So kenapa dia precise and inaccurate? Kita tengok dia punya result of the essay test. So each circle here ni adalah each solution lah. Okay. So all of them jatuh close to 95%. So tarik line ke bawah, close to 95%. So dia tidak accurate sebab kalau seseorang tu accurate, dia punya readings of the solution mestilah close to 100. So all of them jauh daripada 100. Therefore, this student number 2 is not accurate. Tapi dia precise. Kenapa dia precise? Because all of the solutions all fall close to each other. Okay, close to 95%. So that means this person, along the process, along the analysis daripada stage preparation sampailah ke hujungnya, somewhere dia buat systematic error. Dia buat kesalahan yang sama berulang kali. So maybe sepatutnya timbang 10 mg PCM tablet tu dia timbang 8 mg saja. So that's why all of them, instead of getting 100, dapat close to 100. So semuanya sama. So he did a systematic error. Okay, student number 3 pula, dia kata kat sini imprecise, tidak jitu, tidak precise, dan juga inaccurate, tidak tepat. Okay, so why is he inaccurate? If you take a look at all his duplicate solutions, not one of them jatuh close to 100%. All of them are all over the place. And dia juga tidak precise because dia tidak boleh repeat the readings again and again. Kalau dia kalau dia dapat kat sini 5 kali macam student kat atas ni, so dia precise lah. Tapi all of them are all over the place, berterabur. So kalau dia punya bacaan, the result of the analysis is all over the place, that means they're imprecise. Okay, and student number 4, kat sini it's a bit interesting, dia imprecise tetapi dia accurate. So kenapa dia accurate? Because one of the duplicate solution fall close to 100%, tapi the other 4 berterabur. That's why dia tidak precise. Okay, so this is from here kita boleh assess what could cause this. Okay, this is not systematic. Dia tidak buat kesalahan yang sama berulang kali. So it looks like this person has performed, has made a random error. Dia buat, maybe dia salah timbang. Okay, maybe sepatutnya timbang 10, this one dia timbang 6 mg. Okay, sepatutnya timbang 10 mg. Kalau timbang 10 mg macam this student number 1 here, all of them got 100%. Tapi dia hanya timbang satu saja 10 mg. The rest dia timbang 15 mg, 12 mg, 7 ke 5 mg. So that's why dia punya dilution concentration of the solution tu all over the place. So the instrument yang kita guna untuk test the solution give out readings like this all over the place also. Because our measurements are all over the place. Okay, so this is the importance. This is why kita nak tahu types of error tadi. Okay, systematic ke, random ke, ataupun gross error. From there kita boleh fix the problem. We have like a flow where to go next. Bila kita analyze the results, the reading, okay, berterabur bacaan ni. Kenapa berterabur? Maybe this is caused by a random error. So where could we have performed this random error? Masa buat dilution ke, masa buat timbangan ke. Okay, so this is why kita nak kita mesti tahu apakah itu accuracy, what is precision, and the types of errors. Okay, so let's take another break. Kita lewat petang ni, so kita take another 5 and then kita akan habiskan bahagian ni. Okay. Okay semua. Saya nak test this quizzes. Boleh handle tak boleh handle ramai-ramai ni. So saya nak buat satu quizzes. But don't worry, it's not about apa nama instrumentation analysis ke. It's just a random quiz. How do I share? Where's the link? So saya nak minta kamu semua tolong join the link for the quizzes. Ada kat dalam chat room. So just click on it. Dia nak test whether dia boleh handle or not this many participants. So next time kalau boleh handle, saya boleh guna the quizzes session. Everyone boleh participate dalam the nama exercise quiz. You boleh join, tak perlu bubuh nama kamu pun, tak perlu bubuh matric number, just put whatever. Saya tak tahu berapa ramai maksimum quizzes boleh join. Okay, saya nampak sini ramai orang tengah join. So, masih lagi okay. 45. Masih 80 here. By the way, bagi yang masuk lambat tadi, belum sign in attendance, post the link tadi for your attendance. Okay, 54, boleh lagi. Boleh buat 20 lagi. Jangan, kita tengah tunggu lagi kalau ada tengah join. 62, 63. Sometimes kalau internet kamu pun problem, boleh affect juga. Terkeluar from the places ke. Okay, 60, that's like more, that's 2/3 of your, most of your cohort. You know, almost 70. Okay, kalau dapat 70 kita start dulu. Okay, yang lain tu masih boleh try lagi. Kalau bila saya dah start. Alright, so kita akan mula dulu. Yang masih nak try lagi tu just try to join in. Okay, so starting now. Oh, ramai pula masuk tiba-tiba. Okay, 72. I'll start right now. So this is just a random quiz. It's not about chemistry. Tapi kita buka start. Okay, lanjut juga boleh. Dah lag dah. This is probably my laptop. 77 players. Kalau saya show. Okay, semua orang boleh participate. Okay, saya tengok kat sini semua orang boleh join. Ada 83 players. Ramai sangkut ni. Ni yang baru join ni, yang tak gerak ni sebab baru join ke sebab internet problem. So yang siap awal ni semua no problem with your internet connection, with your tak ada lagging ke apa ke. Ramai yang stay until 50. Tak ada. Interesting. Okay, 57, almost 60 done. 2/3 of the class is done. Okay, so from here saya tengok macam okay, except for a few at the back here. Sample about 10 of you. Maybe internet problem. Okay, ramai orang tahu about calories. Okay, so maybe dalam in future classes saya boleh gunalah quizzes. Zizi. Tap the ball. Okay, baru start tenang. Okay, sorry, I took a snack break. Alright, so thank you for participating in the quiz. So from here, tengok semua 72 from 83 are done. And most of you did very good also. Okay lah, okay, so from here saya boleh I'll end the quiz lah, ke masih seronok nak buat ni. Yang buat bawah ni. Kita habiskan dulu lah. 5 more minutes. Dan kita akan sambung kita punya lesson. Okay, so thank you for participating. Saya tengok kasi semua dah done. 84 players. So from here, I think saya boleh guna quizzes for apa nama in our lesson. Saya suka guna quizzes lesson. Okay, because dalam quizzes lesson dia ada feature for slides, and also after a few slides saya boleh attach questions, exercises, so that you can do in between this slides. Saya boleh assess your comprehension. Kamu faham tak what I just said in the past few slides? Okay, so from there saya bolehlah address the issue kamu tak faham bagaimana kamu tak faham. So that's why saya suka guna quizzes. So kita buat this just for test lah, nak tengok boleh handle tak boleh handle 80 orang. Looks like no problem. The problem could be, kalau nak ada problem from internet connection lah, personal individual punya internet connection. Dekat sini okay, so thank you for participating. Kita boleh resume to our regular content. Alright. Okay, so kita dah habis bahagian accuracy, precision dengan the types of errors. Okay. Alright, so here kita ada dekat towards the end of chapter 1 dah. Kita nak tengok the type of analysis. Okay, the breakdown of analytical methods. Okay, macam saya cakap, ada pelbagai kaedah untuk kita buat sesuatu analisis. Macam nak menimbang, kita boleh guna different instrument, ada different units, okay, and those units come from different kaedah, different instruments. So we choose the one that is best suited for us lah, yang kita punya requirement, kita punya condition, alat apa kita ada, okay, kita punya personal terlatih dekat mana, reti guna tak reti guna this instrument, reti buat kaedahnya ataupun tidak. So we choose the best method according to our needs and condition. Dekat sini dia bagi pecahan, the types of analysis. Ada dua jenis, qualitative dan juga quantitative. I spoke about this briefly in the beginning tadi. Qualitative analysis ni kita buat test yang hanya kita kenal pasti dia punya spesies sesuatu bahan tersebut. Ini contohnya apa nama, macam API, Active Pharmaceutical Ingredient untuk PCM. Kita dapati dia punya functional group yang ada dalam PCM paracetamol tu adalah alkohol, OH. So kita choose a test yang boleh detect kehadiran OH. So test-test yang boleh detect, identify species sesuatu bahan ini, kita kenali dia sebagai qualitative analysis. Dia tak bagi maklumat macam berat dia berapa ke, percentage kandungan, the purity, dia tak bagi those kind of information. Tapi dia bagi tahu, dia bagi hint that this is an alcohol. The API is indeed alcohol. The API of chlorpheniramine is indeed amine. Dia kenal pasti the species or the functional group of the substance. Itu qualitative analysis. Dia punya root word kat situ adalah quality. Kita tengok dia punya quality of the substance. Berbeza dengan quantitative analysis, kat sini kita buat test, kita nak kenal pasti, okay, what is the dose, berapa miligram chlorpheniramine tablet ni, okay, 4 miligram. So the API should fall within 3.8 hingga 4.2 macam kita dah tengok dalam STP tadi. Okay, so quantitative analysis adalah test, adalah analisis di mana kita nak determine some sort of numerical information about the sample, dia punya content, dia punya dose, amount, percentage, purity, dia punya weight, all that sort of thing. Kalau kita ukur a value of some sort, itu adalah quantitative analysis. The root word kalau kamu nak ingat is quantity. We are trying to determine some sort of quantity of the substance. Okay, so these are the two types of analysis, qualitative dan juga quantitative. Macam mana nak bezakannya, kita tengok dia punya cara, apa nama, the purpose, the objective of the analysis. And then kat bawah of this slide saya dah buat pecahan lagi, the types of methods pula. Ada classical methods and instrumental methods. So from the name, macam mana kamu nak bezakannya, macam mana kamu nak kenal pasti sesuatu method tu adalah classical ke, instrumental ke. From the name it implies already, instrumental methods adalah kaedah, are methods that we perform using instruments, alat-alatan. Okay, contohnya macam buat conductivity test, spectrophotometry test, chromatography. For classical methods, we perform those analysis without using instruments, without using machines lah basically. Okay, kalau kamu tak nak tahu instrument conductometer, spectrophotometer, chromatography, basically classical method tak guna machine. Instrumental methods guna machine. So dalam next slide ni ada tunjuk example of classical methods, kita boleh perform extraction. Saya nak play video ni takut lag pula, but basically kamu boleh tengok sendiri kalau kamu download this video. Oh no, dia akan play dalam browser, tak silap saya. Yes, as expected. So this is a video of extraction. Dia nak extract acetyl salicylic acid. Itu salicylic acid saja. Dia ada ubat penicillin tablets, and dia nak extract keluar salicylic acid. Sedap. So, we wait for the video to load. Allah. So in this video dia tunjuk macam mana nak extract, macam mana nak keluarkan acetyl salicylic acid from aspirin tablet. So acetyl salicylic acid ni adalah the API, the active ingredient of aspirin tablets. Without acetyl salicylic acid, aspirin will not work as the painkiller, sorry. So this is what how the chemical compounds looks like. Macam mana they explain macam mana they perform this extraction. So this is what acetyl salicylic acid looks like. So it is it's an apa nama dia? It's a type of amino acid. Ada C double bond OOH kat sini. Dia also ada functional group alcohol kat sini. So ada two functional group kat sini, COOH dan juga OH. So they explain macam mana nak extract. Dissolve dalam methanol, dia akan dapat an ester kat sini, methyl salicylic. Kalau kita buang carbonate, carbocation CO2, dia dapat this phenol right here. So this is salicylic acid. Dia nak extract keluar from from aspirin tablets. So this is how dia akan buat. Dia akan ambil the tablets, dissolve dalam acetone, and then dia akan panaskan sampai semuanya larut, and then dia akan dia akan filter, and then dia akan crystallize the sample. Tapi tak boleh. Okay, so macam mana kita nak perform classical method extraction ni? Kita grind dulu the tablets. Ambil tablet, aspirin tablets, hancurkan dia with a pestle and mortar. This is how we perform kita nak ground any tablets in the lab, and after we have ground the tablets, I can fast forward. This is the powder, and then we will dissolve this in 1 liter of acetone. So bila dah dissolve everything, semuanya larut, dia akan filter menggunakan vacuum filter. So the tuang through this vacuum filter, dia akan sedut all the solution, separating the solid from the solution. Kita akan dapat, bila kita filter ni, we only want the solution because in the solution ada acetyl salicylic acid. Everything else is in solid form. So kita dah extract dah, tapi cuma kita nak asingkan pula, kita nak separate. And then kita akan panaskan that solution yang dah diasingkan from the solid, and then we will get this crystal powder here. So this is acetyl salicylic acid. So this is an example of classical method. Kamu tengok sini dia tak guna sebarang instrument. No machines are involved in performing that extraction method. So berbeza dengan instrumental method. Kat sini, this is spectroscopy. So bila kita nak perform spectroscopy, we will go into detail what exactly is spectroscopy dalam chapter 6. But for now, just understand spectroscopy is an analysis that we use an instrument. And this instrument is known as spectrophotometer. Dalam video ni ditunjuklah macam mana kita boleh perform spectroscopy menggunakan spectrophotometer. Tunggu, ada iklan 2 kali. So kalau kamu video yang saya tengah play ni kamu tak dapat tengok dengan clear, you can watch these videos yourself on your own device. This video is linked to the lecture note yang saya attach dalam Google Classroom. So you can go to Google Classroom, download the lecture note, everything. So this analysis is known as UV visible light spectroscopy. So kita perlu prepare one solution, prepare the solution that we want to analyze, and then masukkan dalam this instrument. Tak tunjuk this instrument. So this is what we know as spectrometer. Not fast forward, sorry. So this is the instrument. So this is the inside of the instrument. So we prepare the solution, masukkan dalam this cuvette, this glass vial here, masukkan dalam ni, and then just tutup this lid at the top, and then just press the buttons that we need to press on the side here, and then the readings, okay, of the solution will come out on the screen. Okay, so everything is done through this machine, through this instrument. So any analysis that requires an instrument is known as instrumental methods. Any analysis that we perform without instruments, without machines, those are known as classical methods. So the name should imply lah, kamu boleh macam derive yourself. What they call this analysis, there's no machine involved. So therefore it is a classical analysis. So these are the types of the different types of analysis. Kita ada chromatography. Kalau nak perform chromatography method, ada pelbagai instrumen, ada pelbagai teknik. Ada HPLC, TLC, GC. Kita akan go through this instruments dalam chapter 5, chromatography. Kalau kita nak perform volumetric method, ada multiple types of titration. Acid-base, redox, complexometric, precipitation, gravimetric analysis. Kalau kita nak perform spectrophotometry, ada ultraviolet spectrum, ada infrared, okay, ada atomizer, AAS. So kita depending on what type of test kita nak perform, kita boleh choose what type of methods yang kita nak, and bila dah tahu types of method, kita boleh pilih instrumen apa yang kita nak. Right? So going back to the answering this question, what is exactly quality control? QC is a method to control errors in analysis. Ini the rough explanation, definition yang saya bagi in the beginning tadi. Okay, tapi in reality, QC actually they perform multiple tasks. Okay, they perform sampling, they perform testing. After they perform all the tests, they need to document. Okay, they need to write reports, and then they will submit all those documents and reports to the QA to be reviewed, and then barulah kita boleh release the test, the product that has been tested by QC. So it's basically kerja QC ni bukan limited to testing saja. It involves everything from sampling sampailah to documentation. Everything needs to be documented. Everything needs to comply to the guidelines. Ada pelbagai guidelines that need to comply to. All of them need to be adhered to. And this is due to the seriousness the seriousness of the consequences kalau all these guidelines tidak dipatuhi. Kita nak pastikan the drugs are safe and efficient, berkesan dan selamat. Okay, so all those things relies on how well we perform all of these things: sampling, specification, documentation. Okay, so this is basically the definition of QC. Okay, they perform sampling, specification, testing, documentation, and the release procedures. And these are the roles of QC. Ada 3 kesemuanya. Kita perlu pastikan all the products meet requirement, meet standards. That's the first job. Second role adalah identify the products that do not meet specification. Kenal pasti barang-barang yang tidak menepati syarat. And then lastly, investigate. Kenapa barang-barang tersebut tidak menepati syarat. Something is wrong somewhere, production can be halted, kita boleh perform a thorough investigation. Okay, so role of QC ada 3. You can get this from the lecture note. The end. Thank you for coming to my lecture. That's the first chapter. So after today, saya akan post the first tutorial yang akan diambil kira sebagai your assessment dalam Google Classroom. So please, kamu akan dapat notification lah bila saya post dalam Google Classroom tu. Please do them. Kita akan discuss dalam next class. Okay, 1 week. Yes, 1 week. So next week kita akan discuss. First thing, dalam kelas next week kita akan discuss dulu. And then kita akan masuk new chapter. Alright, and an announcement, hari Jumaat ni kita akan buat lab class. Okay, combine juga. And lab class ni saya akan explain in detail hari Jumaat nanti, tapi secara kasarnya kamu akan form groups juga, buat dalam group juga. Kita tak boleh nak perform actual practical class, kamu tak boleh nak buat all those tests. Tetapi saya akan buat like a virtual lab lah. Saya akan guna quizzes juga. So dalam quizzes kamu boleh kamu boleh buat task, kamu boleh buat quiz dalam group. So you will still have to form group. And saya limit to 5 ataupun 6 saja because kamu ada 81 orang kat sini. So kalau banyaknya orang. That's why saya guna quizzes because quizzes yang akan mark grade all the day. So dalam setiap macam contohnya test number 1 saya akan bagilah saya akan refer to the lab manual. Saya akan bagi questions like okay, what are the apparatus needed for this experiment. So you work in a group, pilihlah from the options that I gave, referring to the rujuk balik to the lab manual. So that's how we are going to perform virtual lab class. That's the first part. And also kita akan refer balik YouTube videos of how these experiments, this analysis is performed in the right condition lah dalam matematik. And then baru kita buat those assessments. So my point is kita akan guna quizzes juga. And kamu masih perlu form group because this will be considered for your group markah group kamu for your grade, for your assessment, continuous assessment. Alright, so in detail saya akan explain lagi lah dalam kelas hari Jumaat nanti. Practical class, combine juga 35 dan 36. Okay, any questions?
Sir, nak tanya boleh?
Ya.
Group members tu boleh pilih kan?
Ya, kamu pilih sendiri.
5 ke 6 orang je eh?
Ya, saya.
Alright, thank you.
Sama-sama. Okay, clear. Kalau tak ada, itu sahaja hari ini. Make sure everyone sign in attendance. Kalau tak ada apa-apa, thank you. Please be alert for your any of my postings on Google Classroom. Okay, recording of our classes saya akan upload dalam Google Classroom juga. Okay, saya akan upload dalam YouTube and then I link the YouTube videos dalam Google Classroom. Tapi the videos are very big, so it takes inilah masa sikit. Okay, terima kasih semua. See you on Friday. Bye bye. Stay safe.
Thank you, sir. Thank you, sir.
Thank you.